All right, so let's look at where the cofunction identities come from. So the cofunction properties, it's actually pretty simple, the idea. If I give you a function like sine and an angle like 20, and you give me the cofunction, like, so sine and its cofunction are cosine, tan goes with cotan. If I give you an angle and you give me its complement, then the sine of the first angle and the cosine of the complement have to be equal. And it doesn't matter what these are. I could switch them, 70 and 20. They're still complementary, and one is a function and the other is its cofunction. So let's, if I said cotan of 100, well, its cofunction is regular tan, and the complementary angle to 100 is negative 10. So these guys are going to be equal. If I said secant of 90.2, then you know that's going to go with cosecant of negative 0.2. Right? So there are a lot of these that you can come up with. It's kind of a convenient thing to know, but we haven't proven it. So I'm going to prove them graphically. So what I'm going to do is I'm going to start with the graph of sine theta, and what I want to do is manipulate it till it looks like this. So first, I'm going to turn it into sine of pi over 2 plus theta, which is the same thing as a shift horizontally to the left by pi over 2. And then I'm going to reflect it. I'm going to change that theta to a negative theta. So that's going to be a reflection across the y-axis. Okay? So, let's see here. Let me shift this thing. So if I shift it, they're shifting it by, what did I shift it by? Pi over 2. And then if I reflect this thing across the y-axis, you can tell it's going to look exactly the same when I spin it around that axis. So the graph of this thing looks just like cosine, which is what it is. So that's how we graphically show that sine of pi over 2 minus theta is the same as cosine theta. Let's, if I actually take this one, let's say I take cos theta now, and I end up wanting to turn it into this graph. Well, that's going to be the same thing as shifting. So if I turn this into cosine of pi over 2 plus theta, that's a shift left horizontally by pi over 2. And if I then switch the theta to a negative theta, that's going to be reflect across y. So let's do that. If I take this graph and I shift it left by pi over 2, right there, and then I got to flip it across the y-axis, I'll do this in a different color, then it's going to look like this. This part here is going to end up over here. This part here down below is going to end up over here. Right? That's going to end up over here. This is going to end up over there. This is going to end up right there. And if you look at this red curve, well, I'm just getting the sine curve back. So cosine of pi over 2 minus theta is the same thing as sine theta. We'll do one more. We'll do, I don't know, let's do a tangent one. So let me block all this off and get rid of it. And I will graph tan theta right here. So here's one asymptote at pi over 2. Here's another one at negative pi over 2. Here's tan theta. Whoops, that's not right. That's got to go through pi over 4, 1 and negative pi over 4, 1. So this is going to be kind of steep. So it sort of looks like this. And I'll do another period over here. About there. Okay, so what we need to do is the same thing that we've done in these other ones. We're going to shift horizontally left by pi over 2, and then we're going to flip it. So if I block what I need here, hopefully nothing else will block. I'm going to shift it by pi over 2, so this ends up at the origin here. Uh-oh, that didn't work. Let's hope this works. Shift it over by pi over 2. Now I need to reflect it across the y-axis, which I think, if it's centered, I'm allowed to do it this way. Boom. Awesome. Okay, so if you look at that, that's the graph of cotangent right there, which is what we're supposed to get. Tan of pi over 2 minus theta should give me the graph of cotangent. If I did the same process again, you're just going to get tangent back. Let's see, how are we doing? Let's do the secant one and show that it's the same as cosecant. Whoops. So let me just erase all this. Delete. Okay, so secant is, let's see, that one's 1 over cosine. So that one looks like this. Asymptote here, asymptote here. So here's secant. I'll just do these two. Yeah, we'll just do those. So in order to turn secant of theta into this guy, I'm first going to add pi over 2 to it, which is the same thing as pi over 2 to the left. So I'm going to take mine. Oops, let me get that little one. Sorry. So I'm going to take that, shift it pi over 2 to the left, and then I'm going to change the theta to a negative theta, which is the same thing as reflecting across the axis. So I'm going to flip this thing horizontally. And if you look at that graph, that's the same thing as cosecant of theta, which is 1 over sine. And if you notice, here's that sine graph, and it fits. It's like the flipped version, right? So we've basically shown these 4 here, and you could do the same thing if you wanted to show these 2. Okay, I hope that helped.